Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is capacitance, capacitors in series and parallel. Capacitance and the arrangement of capacitors in series and parallel. Capacitors are fundamental components in electrical circuits, playing a key role in energy storage, signal processing, and electronic device operations. A strong understanding of capacitance is essential for NEET aspirants, as it forms the basis for solving many problems related to electrostatics and electric circuits. Capacitance is the ability of a system to store electric charge. It is defined as the ratio of the charge stored on the plates of a capacitor to the potential difference between them. Mathematically, C is equal to QV, where C is the capacitance, measured in farads, F. Q is the charge stored on the capacitor. V is the potential difference across the capacitor. A capacitor is a device that stores electrical energy in the form of an electric field. The most common type of capacitor consists of two parallel conducting plates separated by a dielectric, an insulating material. When a voltage is applied across the plates, one plate accumulates positive charge while the other accumulates an equal amount of negative charge, creating an electric field between them. When capacitors are connected in series, the total capacitance decreases. In a series connection, the charge on each capacitor remains the same, but the voltage across each capacitor varies according to its capacitance. The formula for the equivalent capacitance in a series combination is given by 1 divided by C equivalent equals 1 divided by C1 plus 1 divided by C2 plus 1 divided by C3, and so on for all capacitors in the series. This means the total capacitance is always less than the smallest individual capacitor in the series. The primary reason for this decrease is that the effective plate separation increases, reducing the overall capacitance. On the other hand, when capacitors are connected in parallel, the total capacitance increases. In this configuration, the voltage across each capacitor is the same, but the charge stored on each capacitor can vary. The equivalent capacitance in a parallel combination is given by C equivalent equals C1 plus C2 plus C3, and so on for all capacitors in parallel. This results in a total capacitance greater than any individual capacitor in the combination. The increase occurs because the effective plate area increases, allowing more charge to be stored at the same voltage. To understand the significance of these configurations, consider a simple analogy. Connecting capacitors in series is like increasing the distance between two plates, which reduces the ability to store charge. On the other hand, connecting them in parallel is like increasing the surface area of the plates, which enhances charge storage. This fundamental difference makes each configuration suitable for different applications in circuits. Now, let's discuss how capacitors are combined in electrical circuits. Capacitors can be connected in two main configurations, series and parallel. Each arrangement affects the total capacitance and voltage distribution differently. First, let's look at capacitors in series. When capacitors are connected end-to-end, the total capacitance decreases. This happens because the charge stored on each capacitor is the same, but the voltage divides among them. The equivalent capacitance for capacitors in series is given by 1C_Ceq is equal to 1C plus 1C plus 1C plus. From this formula, we can see that the equivalent capacitance is always less than the smallest individual capacitance in the series combination. This arrangement is useful when a lower capacitance is required or when capacitors need to withstand higher voltages. Next, let's examine capacitors in parallel. In this configuration, the capacitors are connected in such a way that they share the same voltage. The total capacitance increases because the charge storage capacity of the system is enhanced. The equivalent capacitance for capacitors in parallel is given by C_Ceq is equal to C plus C plus C plus. This means that the total capacitance in a parallel combination is simply the sum of the individual capacitance. This setup is useful when a higher capacitance is needed to store more charge. A key point to remember is that in series, the total capacitance decreases and the voltage divides. In parallel, the total capacitance increases and the charge divides. The choice between series and parallel connections depends on the specific requirements of an electrical circuit. Capacitors are used in a variety of real-life applications. Some common examples include energy storage. Capacitors store energy and release it when needed, as seen in camera flashes and defibrillators. Filters in circuits. Capacitors smooth voltage fluctuations in power supplies and electronic circuits. Timing circuits. Capacitors, in combination with resistors, control the timing of electronic signals in oscillators and timers. Tuning radios. Capacitors help in frequency tuning in radio and TV circuits. Medical applications. Capacitors are used in pacemakers and defibrillators to deliver controlled electric shocks. A practical example of capacitors in series is their use in high-voltage applications where the voltage is divided among multiple capacitors to prevent damage to a single capacitor. In contrast, capacitors in parallel are used in power supply circuits to provide a stable voltage by increasing charge storage capacity. Understanding capacitors and their combinations in series and parallel is crucial for solving neat-level physics problems. Many numerical problems require applying these concepts to calculate total capacitance, charge distribution, and energy stored. That concludes today's session on capacitance and capacitors in series and parallel. If you found this explanation helpful, make sure to subscribe to AskPrep for more in-depth NEET physics content. Keep practicing, and see you in the next session. Thank you. This is AskPrep, your guide to mastering NEET preparation. Let's decode complex topics and simplify your journey to success.